Get those mics pulled in nice and tight.
Yeah, there we go. Hi, everybody.
Welcome.
Thank you for having us.
Thanks for having us.
So I want to start with a really bizarre coincidence of mathematics that makes eclipses possible specifically on this planet. What is that about?
So we're very lucky to live where we are in the solar system, not just because Earth is the best planet and where we can live, but
That helps.
so as you might know, there are lots of planets in the solar system. Some planets have moons, some planets don't. We have one moon, and it's a bit of a coincidence that the size of our moon and the distance of the sun make it so everything lines up just perfectly every now and then, that the moon completely blocks the sun and gives us a total solar eclipse. And that's not something you get if you're on Mars. Never going to happen.
But the moon is slowly drifting away from us, right?
It's very unfortunately we aren't going to have total eclipses forever. The good news is it's moving very slowly. Do you remember how many inches a year?
It's about inch and a half.
Inch in a year. Okay,
Yeah.
so if
It
you,
adds up. It adds up over time, though.
So
But
600 million years from now.
That's right.
Exactly.
There'll be no more eclipses.
so please
Total solar eclipses.
enjoy your eclipses while you can.
How often does a place on the Earth experience being in the zone of totality for an eclipse?
Yeah, so it's about, on average, 375 years for a place, but it varies tremendously. So you'll know that the 2017 eclipse and the 2024 cross in some areas. There's little areas in the U.S. that will have 2 total solar eclipses within 7 years, so that's really unusual. And then there's places that have droughts. I like to, right now, Los Angeles is an eclipse drought, and there's almost a 2,000-year period without a total solar eclipse over Los Angeles. So, but over the last 4,000 years, Los Angeles has actually had more total solar eclipses than here in Dallas. So it really does vary. It's just a matter of timing.
As far as we know, they can occur anywhere on the Earth. Is there any part of the planet where an eclipse couldn't happen?
They do happen everywhere. So you even get them. There was one a couple years ago in Antarctica, for instance.
Mm-hmm.
Yeah.
So the alignment that makes the eclipse we're about to see possible repeats itself in 18 years, but on the other side of the planet, right?
Right. So the thing that amazes me is that people figured this out before really advanced mathematics and telescopes. They were sort of, just by watching very carefully how the moon and the sun and all the planets were moving, they came up with this cycle. The hard part is figuring out, like you said, exactly where you need to be. So there were people predicting eclipses, but then they didn't happen because they weren't in the right spot. So that's the key part, right? That cycle repeats in a different spot.
Do we know who the first people were who were able to predict eclipses?
I think there's some evidence that Chaldeans did. It was like in 500 BC. I've been reading up on my eclipse history.
Even earlier, I think the Chinese
Yeah.
had some, but there's also a famous case of Chinese astronomers who failed to predict a total solar eclipse and were beheaded. So, for at least some years, astronomy was a very dangerous career to be in.
I read this week that there have been some updates to the map of the zone of totality, and I was really surprised that I guess it's still a little bit challenging, right, to get like to the zip code level exactly where the eclipse will start and end.
Are you sure that wasn't an April Fool's joke? Because there was one I saw yesterday.
I hadn't seen that.
I actually think it's pretty well known. It's actually interesting to know that Halley, the guy Halley's Comet, who everybody will be familiar with, was actually the first person to kind of accurately predict where an eclipse was. He got it within about 100 miles of where it should be. But it's pretty accurately known at this point. I mean, maybe not the very edges so much. But I always say you don't waste your time. When you know where an eclipse is, go towards the middle as best you can. And thankfully, this year, Dallas is pretty much close to the middle, so we're in good shape here at least. Cleveland, you're in good shape too, and a few other places along the way.
As far as a land path, this eclipse is all about North America, right? And I read that this might be the most watched eclipse in a very long time because of the heavily populated areas. I mean, often much of the path of totality will be over water, right?
Yeah, absolutely. And not only is it over land, but it's passing over, by luck, a number of really populated areas, a lot of big cities. I think there's something like 32 million people who live in the path that don't even have to get in a car and drive. They can just go outside and look right up, which is spectacular. And then because it's passing through a corridor where people do live within an hour's driving distance or less. I mean, millions of people can potentially see this eclipse quite easily. The eclipse in 2017, we were lucky it passed over the U.S., but it went over some beautiful parts of the western United States where there are very few people. So we had some spectacular views, but not as many people just easily able to see the eclipse.
Yeah, this time, I was just going to say, this time there's some big cities that just miss it, like St. Louis is one, Detroit, that are within, a half an hour drive. So this is, people are concerned, of course, about traffic, and that's the reason, because, those are rather big cities that will just be off the path. So I imagine a lot of people in Detroit driving towards Cleveland, for instance.
Serious question. What do you know about what happens to traffic on the day of an eclipse?
Well, I mean, the 2017 eclipse, for folks who tried to get home in parts of the country, it was because they traveled to more remote places that might have 1-2 lane road to get in and out. If all of a sudden thousands of people show up and everyone's ready to leave as soon as the eclipse is over, then it can be a bit of a mess. But it depends on where you are. It depends. It's actually pretty hard to predict. I know there's estimates, for instance, in Texas, and they range in the hundreds of thousands of people, because it depends on who can get off work. And I hope everybody gets a chance to see it. Really, I would love for everyone to get a chance to see it. But I also don't plan to get in a car and drive on Monday afternoon.
Pretty much all of the continental U.S., the lower 48, will be able to see some part of this eclipse, if not the path of totality. But if you'll forgive the pun, the experience is like night and day, right? How different is it?
I've been telling a lot of friends who keep saying, "Oh, I've seen an eclipse," and what they mean is they've seen a partial eclipse. I'm like, "You have not seen an eclipse. You've seen a partial eclipse, not a total." It's an entirely different experience. For someone like myself, even though I've been into astronomy my entire life, there hadn't been a total solar eclipse in the U.S. until 2017, since the 1970s. So there was a long period, most of my career, where I hadn't seen one. And so I had seen many of these partial eclipses and went, "Oh, this is fine. I've seen an eclipse." I was not prepared for 2017, I have to say. And now it has me chasing every single eclipse, and I probably will continue to do that. Now I'm an astronomer, so I might be a little biased. But there are many people I know who are joining us, for instance, here in Dallas this year, who came along in 2017, and then there was an eclipse in 2019 in Chile, where we have an observatory. And so a lot of people have become eclipse chasers, and I'm predicting many people, once they see this eclipse, will become eclipse chasers.
I saw a joke this morning that was, because it's hard to put into words. Someone said a partial eclipse, if it's mostly covered, it's like seeing an interesting sunset, but a total eclipse is like someone broke the sky.
I like that.
And are they different in terms of the experience of watching them? Will 2024 look very different from 2017?
Yeah, so the eclipse itself, it'll look a little bit different for two reasons. The first one is totality will be longer because the eclipse shadow is much larger. So if you're near the central part of the path of totality, you actually get a longer eclipse this time around, anywhere along the path of totality. The biggest difference as far as how it will look actually comes down to the sun's activity. So the solar corona, the outermost layers of the sun that you see during eclipse, it looks a little bit different when the sun is very active, when there are lots of sunspots and lots of activity. It looks different, and we think that's because there's a connection between the corona and the sun's surface. So I look forward to seeing with my own eyes. I've seen lots of pictures, but it'll be interesting to see how this one compares to the eclipse in 2017.
Yeah, I was going to say, in 2017, the sun was at a solar minimum, which means there was very little activity. There were barely sunspots or anything on the sun. And now it's been, as people will know, there have been all these stories in recent months about the flares. And the sun is exceptionally active this time. So it should be quite different, I hope. So it might be kind of fun to see how different it really is.
So this is an 11-year cycle, right?
That's right, yeah.
And how do things change on the sun during that time?
Well, so it's basically the magnetic fields get wound up. You get many more sunspots. This is something that was tracked before we even knew anything about the physics of the sun, just by looking at the sun safely and counting how many spots there were. People noticed that there was a cycle that was happening. And it turns out it's actually a 22-year cycle. The spots peak and go down and peak and go down again, and it's because the sun's solar field is flipping and then flipping back. And it's something that folks are still studying. Where we work is a big part of that history, so we talk about this a lot.
Well, talk about that history a little bit.
you want to take this one?
I'll let you go ahead.
Oh, great.
You started,
So I
you
work,
could finish it.
I work, so we're in Pasadena, Carnegie Observatories. We were the headquarters for Mount Wilson Observatory, which is above Pasadena, and it's a historic observatory. It's been there since 1904, and it was originally established as a site to study the sun. Our founder was a solar astrophysicist. He was really interested in understanding the sun as a star, and our understanding of the sun in 1904 was minimal, very different than what we knew now. And so really fundamental things that we know about the sun, like the fact that sunspots are darker because the temperature is cooler. That was a measurement that was made for the first time using telescopes at Mount Wilson by astronomers working at Carnegie. The fact that there is, that magnetic fields are associated with sunspots, that there are magnetic fields not just on Earth, but outside the planet Earth. This is sort of things that we take for granted were major discoveries that had no precedent as of just 120 years ago. And that's continuing. You know, we're still trying to figure out a lot of the details, but it started with just using telescopes here on the ground and observing the sun.
So ground-based telescopes maybe don't get as much attention as space-based telescopes now. It sounds like there's still an important role for both.
Oh, absolutely. This is a big thing for me. I keep pointing this out. I've been giving a lot of talks about James Webb Space Telescope. Jeff has been doing a lot of great work on James Webb. It's an amazing instrument. It's really helping us revolutionize our understanding of astronomy. It's still a pretty small telescope, and it's very expensive. And our ability to build bigger and bigger telescopes is hindered because they're just too expensive, and we don't have the technology to put them all in space. And so bigger telescopes allow us to see fainter things. This is not really relevant to the sun so much. The sun's pretty bright. But if you've seen those James Webb images, you've seen some of the little faint early galaxies, the first stars in the universe. We're getting close to seeing them with James Webb. And while James Webb can detect them, to really understand what they are, we need the next generation of telescopes, which is something that we're working on very, very rapidly and hoping, in the next 5-6 years, we'll have the next generation of ground-based telescopes.
So we all understand that an eclipse happens when the moon passes between the Earth and the sun, but it doesn't happen every 28 days.
Yeah, and a lunar eclipse doesn't happen every other 28 days. Mm-hmm. So it's something that once we start explaining how it happens, that the Earth, the sun, and the moon are all in a line, you would think there should be an eclipse every 28 days, and it's because sometimes the moon's a little bit above the sun and sometimes the moon's a little bit below the sun in the sky. And that's because the moon's orbit is tilted by about 5 degrees. Is that right? It's just a little bit so that it just happens to go above and below. And sometimes the sun will the moon in the sky will just graze the sun, so you get a partial eclipse. Or worse than that, sometimes the moon's a little bit further because it's orbiting in an ellipse, and you end up with an annular eclipse like we had last October, instead of a nice total eclipse like we're getting next Monday.
Yeah, for people who saw the annular eclipse, how different, again, does the total solar eclipse look?
Have
you seen an annular eclipse?
I
ever?
actually haven't, because to me so maybe we're the wrong people to ask. But I think it goes back to, once again, night and day, because the thing that makes the total solar eclipse so spectacular is the ability to look at it, see the corona, and see some of these things. And with the annular eclipse, you don't see that. It is kind of like a special partial eclipse, is how I would describe it. You cover a good amount of the sun, but not the entire thing.
Like, I kind of want to see one, but you never get to take your eclipse glasses off. You have to always
That's right. You always have to have them on. Yeah.
Does the season in which an eclipse occurs affect it in any way?
You mean like spring, summer, winter, fall? The biggest thing would be cloud cover or weather. But the eclipse itself, so the interesting thing is, in the northern hemisphere, the sun is actually slightly closer in the summer. That's right, or in the fall. In the winter. It's the opposite of what you expect. The seasons are because of the Earth's tilt, and the sun is a little bit closer in the winter. So that means you're slightly less likely to have a total solar eclipse in the north. I'm trying to come up with a difference. I don't think there's really a big thing.
So this is the size of the moon as viewed from Earth varies tremendously. This is why we have these supermoons. You hear about these supermoons now all the time, right? That just means the moon is, during a full moon, very close to the Earth, and so it appears larger on the sky. So that's kind of the biggest factor that tends to distinguish between an annular and a total eclipse, is the size of the moon. But the size of the sun does vary, because our distance, as Jeff is saying here, our distance from the sun also varies. And it is kind of remarkable, it surprises people, that we're actually closest to the sun on January 3rd. and which, as Jeff pointed out, that's not why we have seasons, right? In third grade, we teach everybody that, but we forget everybody. So we're actually on January 3rd, which is usually pretty cold in the Northern Hemisphere, we're actually the closest to the sun. So the sun's size changes very slightly throughout the year, but the moon size changes quite a bit.
My understanding is that the path of totality for this eclipse in 2024 is wider by about 35 miles than the one in 2017. What accounts for that?
Well, once again, this is because the moon is just a little bit closer to the Earth in this case, so it's a wider path. And that makes it a longer time of totality. So it's almost double what it was in 2017 in most places. So we're going to get a nice, 4 minutes, around 4 minutes along most of the path of totality. That's exciting.
Sorry, go ahead.
No, please.
I would say one thing I hadn't really thought about. There's this nice animation online at, I think, Great North American Eclipse. Anyway, it shows a video of the shadow moving across the Earth's surface. And the amount of eclipse you get, again, depends on the size of that shadow. So you can imagine you get more shadow as it's moving across, but it also depends on the angle. So if you're up in, this eclipse is going over Newfoundland and out over the Atlantic Ocean, and the shadow moves quicker and quicker and quicker and quicker as it gets towards the end of the path, just because the angle of the shadow is increasing. So this is the best spot for a lot of reasons in Texas. It's moving nice and slow, so you get a few extra seconds of totality.
I want to talk about how things will play out on the big day. An eclipse officially begins with what is called first contact. What is first contact?
That's when the moon just first starts to cover the disk of the sun, so that very first little bit. And actually, we were here for the annular eclipse in October, and it's good to mention to everyone that's a time to start safely looking at the sun with eclipse glasses or using a pinhole viewer. And if you look, really keen-eyed, you'll start to see that shadow start to creep across the sun's disk in the sky.
But the moon is effectively invisible before that time.
Yeah. The other thing that's happening right at totality is that's new moon. That's when the moon normally would be invisible in the sky, just because it's right even with the sun. It's just you don't see it because you're seeing the Earth side instead of you see the Earth-facing side instead of the sun-facing side.
And how long from first contact for the moon to completely cover the sun in the path of totality?
I have to do the math in my head.
Yeah, it's 12:20 to 1:40. It's an hour and 20 minutes.
Yeah,
is that
something
right?
like that.
Yeah.
Yeah, not very long.
Yeah.
And that is when we might see these things called Bailey's beads. What are those?
Yeah, Bailey's beads are really quite curious. So the moon has structure. It's a three-dimensional thing with geography, just like the Earth. And so you actually, the last few seconds before the moon covers the sun, you can get the sun still shining through kind of some of the dips and valleys. And you get this bead effect. And it's called Bailey's bead after a gentleman named Bailey who first recognized this. And he recognized that was, in fact, evidence that the moon had structure and was a 3D body, just like the Earth. And it's pretty remarkable. And then that's when the excitement really begins, because once you're there, you're really right seconds later into totality.
Yeah, I'm so curious. I have never witnessed an eclipse before, a total eclipse. How suddenly
Very excited.
will darkness fall? Is it like the experience of twilight, and then boom, it's midnight?
Not really.
See what you say.
So I'm curious. I remember the first eclipse we saw in 2017. It was a bright and sunny day. It was warm, and even it was getting close, maybe 10, 15 minutes before totality, and you start to notice the light dipping. It's kind of like twilight. It looks eerie. It doesn't look quite right. It doesn't look like a sunset
eerie.
or twilight that you've seen. I had to go get a sweater because I was in a t-shirt and it was beautiful and I got cold. I was like, I can't stand here through totality. I want to enjoy this. I got to go grab something to warm up. Like it's slow and coming on, and then all of a sudden really fast, I feel like.
I think eerie is exactly the right word I was going to say. For me, I've been describing it as kind of gloomy. It gets normally with sunrise and sunset, the sun's low in the sky, but all of a sudden now you have the sun very high in the sky. It's the middle of the day or close to it, right? And it's being blocked. And so I think that filters the light in a different way. It gets gray and gloomy. And I mean, gloomy is the right word for me. It's almost depressing is how I would describe it. And then when totality happens, it goes to exactly the opposite, where it's this brilliant effect where the corona comes out and it's just the most beautiful thing you've ever seen. But I find it very eerie that 15 to 20 minutes before totality is a feeling and that's the best I can describe it, is eerie. I like that word.
So, Jeff, you mentioned the temperature dropped in 2017. I've read that is likely to happen in 2024 in a lot of places, depending on humidity and other factors. What about other weather? Does the wind change?
I don't see why it would. I guess I'm not a meteorologist, so I
Yeah, we may be out of our
That's a
out of
really
our
good
element
question.
here, but yeah, it is an interesting question. I mean, it is effectively night, right? And so the things that do happen at night, it's not dark like it would be at midnight, but it is definitely like very far into the twilight. And so I imagine there could be some meteorological things that could happen. I don't remember noticing any. Both the last two I've seen, it was very still, and I got really lucky the last two times. It was amazingly beautiful and clear. I think for you too.
Yeah.
You were in the same places. So we'll see this time.
The one thing I read that it does affect is the upper atmosphere. So that there's a couple experiments this time to measure the effect on the ionosphere, because the wind of particles that's constantly streaming from the sun gets blocked a little bit as the moon moves in front of the sun. So that's, again, this is where I'm out of my element, but I read that's an experiment that's going on to measure the impact on Earth's upper atmosphere during and after an eclipse, and just to see how things change.
I was really amazed. I had assumed that we would have all of this figured out. I say we, I mean you. But there are a lot of scientific experiments that can really only be conducted
That's right.
during an eclipse. Talk about some of the ones that are exciting to each of you.
Good.
Yeah, well, I was going to say, when I was in graduate school, a couple of my classmates worked for a solar physicist, and they would travel to anywhere in the world when there was a total eclipse. They went to Bikini Atoll, they went to the Libyan desert, and they would haul all this equipment with them to get just a few minutes worth of data. So I hope everybody enjoys the eclipse wherever they are on Monday. But they would be frantically working for the hours up to the eclipse to watch an instrument collect data instead of watching the eclipse. The thing that you can see during an eclipse is the part of the corona that's as close to the sun as possible. That even with modern instruments, there are ways of blocking the sun's light and taking a picture. It's called a coronagraph. We've had them for a while, but because of optical effects, you don't get as good. The information is not as good as it is during an eclipse. So during the 2017 eclipse, they collected some data that sort of, we can build up hours and hours worth of data because we can keep looking at the same stuff, and they have to stack minutes worth of data every couple of years to get just tidbits of information about the transport of energy and heat from the surface of the sun to the outer layers of the corona. And they do some really cool stuff. There's beautiful pictures where they took images of the sun's corona and all these different atoms to try to measure different temperatures to then tease out the tiny details of the physics. It's tough, and again, I'm waving my hands because I'm not a solar physicist. I don't know the details, but I'm really excited to see what part of it is. They'll have newer and better cameras that can get better images this time than they could the previous time and the previous time.
Mm-hmm.
I think that's the big difference, is they'll be able to get more information this time than the previous time. So I'd be interested to see what they learn now that they didn't know last time. It's a good question because I don't know either. It seems like they should have figured this out, right?
Yeah, I mean, I think one of the remarkable things is the sun is the nearest star for us, and it's the only star we can study in detail, but it still is very mysterious in many, many ways. And I think even the corona itself is actually much hotter than the surface of the sun. And there's not really a full understanding of why exactly that is. I mean, there's lots of ideas with whipping of the magnetic field and various things, but that seems like something pretty basic that we still don't know. So this is why observations with the total eclipses are very important, I think.
Part of the problem is because we can study the sun in such amazing detail, it challenges the theorists using computers to try to model and recreate the sun. We're very lucky that the things we look at are very far away, and so we can kind of gloss over a lot of that. But if you have this incredibly complex magnetohydrodynamical simulation that can only simulate a tiny piece of the sun's surface, I can see where the challenge is when there's these beautiful images of the sun taken by scientists and spacecraft that far exceed our ability to model and understand the physics of what's happening.
When you say surface of the sun, is that really just a metaphor?
Yeah.
Well, it's not a solid surface like the Earth, if that's what you mean. Yeah, it is not. But it is what you're seeing when you see sunlight. That is, you're being dominated by that surface of the sun. And so that's why totality is so great, because it's the only time you really can block that and see the rest of the sun, which is really quite interesting.
Is there any particular experiment that you've been following?
So one thing that I think is really quite interesting is that astronomy now has a lot of what we call citizen scientists. These are amateurs, amateur astronomers. You can buy all sorts of great telescopes and filters, and there's amazing photography among some amateurs. And one of the things that will happen in this particular eclipse is that they've asked people who will be looking at the sun during totality to snap lots of images of the corona, and we'll be able to watch how the corona changes along the path. So you'll have people in Mexico, you'll have people here in Texas, people in Ohio, and by seeing how it changes over minutes to hours, you're going to get a sense of how rapidly the corona changes. And it likely changes on very fast timescales, but this is something we'll actually probably learn a lot more about from this particular experiment. What I love about it is it allows the average person, well, not exactly average, you have to know how to, you do have to have the equipment and know what you're doing. And it's probably a little late for most people to learn that, and you want to be careful because it is the sun. But having that data, it allows amateur astronomers to play an important role in science. And this is something that's happening a lot. And I know for me, when I was a kid, I would have loved to have an opportunity to participate in an experiment like this, right? And so it really will have an impact on what we know about the sun. I think that's really powerful.
I love that because it harkens back to the days when astronomers would write to each other over long distances and say, can you be in this place on this date to just watch with your eyes and record what you saw? That still happens, I guess.
It still does. I'll tell you a story about me because I always say I was a born astronomer. I was into astronomy when I was like 5. My mom recognized this and got me books. But there's only so much you can do with a small telescope back in the days. You can do a lot more now because they're great. But when I was a teenager, I was still very fascinated with astronomy, and I wanted to do research. And so one thing I did was I would watch meteor showers. And you can watch meteor showers, and you could actually trace where on the sky you saw particular meteors, and you would do that over many hours. You actually learn something from that. You learn a lot about where the meteors are coming from, where the stream is coming from. And I actually had that published. It was not published in a real, even Jeff's looking shocked. Cool. Yes, I had my first publication, not in a real journal, but it was in there was a children's astronomy magazine at the time that I was able to publish this in, and that was super exciting to me. I actually was doing an experiment as like a 12 and 13-year-old kid, right? And nowadays, it's much easier to do that. And so for me, when people say, what's the most exciting thing about the eclipse? I have 2 things. One is that there are so many people I know, including you, Krys, who's never seen one and are going to get to see this. And you are going to be speechless. And afterwards, you're going to say, you did not even sell it enough to me. That's how exciting it's going to be. I promise everybody.
I'm glad to hear this because I've been excited about this for, years.
Oh, good.
When I realized that I lived in Dallas and it was going to happen here as well as other places in the U.S., but I'm afraid because I've looked at so many videos and pictures and read so much.
It has not prepared you for what you will experience on Monday. So that's the first thing. And I have many, many friends who are in that similar situation. So I'm very excited for them to experience this. But the second thing is this will be a huge inspiration for young children, right? There are those little Jeffs and Johns out there and Susans and Marys who hopefully will get to experience an eclipse, and that will maybe send them on a path to a career in science. It doesn't mean they'll all be astronomers, that we don't need 1 billion astronomers in the world. It's a small field, but it's an exciting one. But we do need people in technical fields. We need people who study computers and engineering and all of that. And this is a way to kind of get, I think, young children involved in science. And so I think that's super exciting.
So we talked about Bailey's beads. We should also be on the lookout for these things called prominences. What do they look like?
Prominences are... they're really cool. So those magnetic fields that cause sunspots, they can cause these big arcs of plasma to loop up and off the surface of the sun and come back down. Normally you'd need a special little telescope to see them, but you might be able to see if there's one happening, they happen when the sun is really active. You can see them right at the edge of the sun's disk during an eclipse. I don't know, because we saw solar eclipses when the sun was near its minimum. We didn't get to see something like that.
I saw a little one in the images from 2017. I didn't see it with my own eye, but the images from 2017 had a little one, but we should be really lucky this time. It'd be shocking if we didn't see one of these things. That'll be really cool.
And they're pink?
They can be, yeah, really pink, purple. It's a beautiful color.
So we can see those. We don't need magnification to be able to see those.
If it's a big one, yeah.
You should be able to see them, hopefully. Yeah. I would predict on Monday, given how active the sun is, that you're likely to see such a thing. I mean, there's been a lot of talk, of course, about there have been these huge solar flares I mentioned earlier. If there happens to be a big flaring event, then this might be associated with some very visible features like that.
So will we be able to see other stars in the sky if we live in in an urban area? It's hard to see the stars. What might we see?
Well, the biggest problem in urban areas at night is that the lights are on. The good news is during the day, most of the lights will be off. So, and if you manage to switch the sun off, you'll actually be able to see some of those stars poking out. Right now, there's a lot of planets close to the sun, so that's one of the most interesting things you'll be able to see. It's a bummer for evening stargazing because we love to show off the planets, but I guess for a few minutes, you'll be able to see those planets that are close to the sun right now.
And I was going to say Venus is particularly bright. So people have, if you've ever seen that bright star in the morning or evening sky, it often is not a star. It's usually Venus. Venus and Jupiter will be up, but Venus is pretty close to the sun. So almost certainly if people are during totality, you'll notice Venus. It's kind of hard to miss. You can actually see Venus during the day if you know where to find it. It's one of the three things, along with the moon and the sun. That's pretty much all you can see during the day, but yeah.
What about Devil's Comet? Will we be able to see that?
Is that what it's called?
It's changing name. The answer is no. It's way too faint to see without a telescope, unfortunately. Now there had been this hope. This comet has had flaring episodes itself, where it's gotten very, very bright, and so unless there's some really huge explosive event on the comet itself in the next few days, it's unlikely you would see it. It is technically visible with the naked eye, but it's in a dark sky, and so my guess is we made a big deal of it because it would be super exciting if it did flare up, but it seems highly unlikely.
Comets are tough.
Did I use a canceled term for that? Is there a better phrase that I should use?
Actually, one of our astronomers flagged this just in case a few weeks ago, just in case during the eclipse we'd be able to share it with people. And it had whatever comets are named after the people who discover them, and I already forgot the name of the people who discovered it. But really popular astronomical objects take on a life of their own once they get a good name like that. So
So the next phase is third contact, right? That's when the moon starts to move away from blocking the sun entirely. Is it still worth watching? I mean, does everybody give up after that?
Yeah,
You're shaking. You're
yeah.
nodding your head.
You're going to be so done at that point. I mean. Right. We will, in theory, continue to watch it. But even this happened with the partial eclipse here in October. We had a lot of people here at the Pro Museum, and everybody was so excited till we got to that point where it was maximum, and it wasn't a total eclipse. But even that, as soon as we hit that point, everybody kind of left. I think it is very anticlimactic after totality. What you'll be doing is you'll be going home and planning where you're going to be in 26 when the next eclipse happens. And the answers are Greenland, Iceland, or Spain.
Oh.
Some good options there.
Yeah, absolutely.
Except the weather in Greenland and Iceland may not be so good.
So in third contact, when it's first happening, there might be these bands of shadows that move across the land. What are those?
I've seen the shadow in Las Caponas in Chile. I saw that before, but actually before the eclipse, you can also see that as well. And so sometimes you can see the shadow approaching. I have to say in 2017, I didn't notice that at all. And I'm not sure how noticeable it really is.
I think you have to be in the right place topographically. Like you have to have mountains or something. You can really see it moving. It's tough. The best pictures I saw of that was someone who was on top of a hill and looking down, and you could see the shadow approaching.
One of the, I'm going to call it a benefit. If it happens to be cloudy where you're at during totality, which it won't be, hopefully for most people, because it won't be as spectacular. But I have not seen a total eclipse during cloudy conditions, but there are claims that you can sometimes see the shadow on the cloud. So it's something to look forward to. It's not the same as the real event.
I wanted to ask you about that. It will get completely dark, right?
Even if it's cloudy, yeah.
If it's cloudy.
Yeah. Yeah, it just would be very disappointing.
If you haven't seen an eclipse before, you don't know that.
Actually, that's true. It just makes you more eager to book your trip in 26, maybe. I don't know.
Do you have colleagues who have traveled somewhere to see an amazing eclipse and met clouds?
Yeah, I mean, absolutely.
Well, I was saying earlier, if it's cloudy, you actually get the true astronomer experience because many of us I've been to Chile 135 times. People are always impressed by that number. I was going 6-7 times a year, and there were times when I would travel, and Chile has amazingly clear weather. It's like clear 90% of the time at our observatory, but it still has a winter, and you can get clouded out. And I have traveled 5,000 miles and been clouded out, and that is part of. And you were going to discover the next big thing, and you're clouded out, and that's super disappointing. But that is the astronomy experience. We do sometimes have clouds. So,
what have you learned about coping with that frustration?
You go again. You just go to the next one, right? And that's where it becomes a little more challenging with the eclipse because you have to wait, almost 18 months to go see the next one. So,
Do you have both of you imagined the most amazing place to see an eclipse if it were in a spot? I mean, is there a particular kind of topography where it's best? Would you want to be on a mountaintop or on a ship in the ocean?
We were also talking about how I hope that I'll be able to travel for eclipses because it's a great excuse to go on a vacation. So I think of like my best vacation spot, like a nice tropical island to see. When we were able to travel to Chile, near Las Campanas, I think that was a really great place to watch an eclipse because you could see a lot more of the landscape. There weren't as many people around. It was really. I heard a lot of people who traveled to Oregon and Idaho when they were sort of by themselves out. That was a really nice, wonderful experience. But I've also never experienced an eclipse with thousands of people around. I'm really excited to see what that's like.
There is an eclipse coming up in a few years over Egypt, so I imagine that might be one that's going to be quite popular too. So you can plan, as Jeff says, your vacations around eclipses. And I know a couple who are coming, joining us here in Dallas, that they went for their honeymoon on an eclipse, total solar eclipse, and now they do every eclipse as part of it's something they do as a couple.
Wow.
This is, I think, their 14th or 15th eclipse. Yeah, it's crazy.
How was the eclipse of 1919 used to test, not prove, I guess, Einstein's theory of general relativity?
So one of the things I love about astronomy is we've been able to help folks understand the universe and actually prove those ideas multiple times over. And this was one of the first big proofs of general relativity. And one thing that relativity says is that the sun or anything that's really massive should bend light. This is something that we use regularly now, this knowledge, but that was not yet proven, but proposed by Einstein's theory of relativity. He actually wrote George Ellery Hale, this astronomer I mentioned earlier who founded Carnegie, to ask for advice on how you would do those observations. And in 1919, there was an opportunity because the theory had been proposed. People had talked about how would you observe the sun bending light from a star that's on the other side of the sun. So you imagine that there's a star, everything lines up just right, and that star's light passes close enough to the sun that it actually gets deflected measurably. And I'm going to wave my hands because that measurement is really difficult to make, especially in 1919, especially because you have to be in the right place to watch the eclipse. You have to have the right equipment. You have to be able to make those measurements. So it was a really difficult measurement to make. And Sir Arthur Eddington was the person who actually went. And there were 2 expeditions. I was reading up on this. There was data taken in 2 spots, which, again, great idea. Get as much data as you can. What if it's cloudy in one spot? You'll still get data in the other spot. And they made this really tiny measurement. It's an arc second of deflection.
Very small,
right?
yeah.
So a 1/3600th of a degree, which that's, I don't want to say it's easy now, but it's not. It's tough. That's a tough measurement to make. That's not even that's not exactly an easy backyard experiment even now.
Well, I like you explaining that Einstein wrote to a colleague and said, how would you test this sort of thing? Because I think for the general public, we just assume, the experiment working, that's the success, right? But you have to be able to devise how to test these things. There's so much creativity in science that I don't think you get enough credit for from people.
Oh, no, we agree with that. No, but you're right. It's actually, so you may have a scientific question, but the question is, what experiment did you do to answer that question? And in this case, Einstein understood that the sun should bend the light of a star, but he had no idea how to observe it because that wasn't his thing, right? I mean, he was a theoretical physicist. And so he went to George Ellery Hale, who was the expert on the sun at the time, to propose, what would I do? And we work like that all the time. We always work with people around the world. I always say to people, you go and find the other person who will help enhance what you're trying to do because they have that specialty that you don't have. And that's the way science works.
That's a story that we like sharing with, especially kids who are learning about science or who don't know. A lot of people don't think about how science happens. We have a picture in our library of when Einstein came and visited to discuss a lot of the new discoveries that were being made in astronomy because I hear he's a very smart guy. He's very good at what he did, but no scientist is working in a vacuum. We're all working together collaboratively to try to move things forward, and that's a really great example. There are many great examples. We all sort of need each other. And talking is how we figure new things out.
I also learned recently that Eddington experiment caused Einstein to have a new respect for people that were taking these very minute measurements. Like he had thought, these guys are just a little bit too pedantic, and suddenly he realized.
Yeah, that's right. I mean, once again, he probably could not have done it himself, right? He needed somebody who knew how to do this. It was an exceptionally difficult experiment. I think even today it would be in many ways. And so for somebody to be able to do that and prove his theory was really remarkable. And I should say that that's why we know who Einstein is, right? I mean, at that point, general relativity had been around for a few years, but it wasn't like Einstein was a household name. It really made Einstein a celebrity in 1919. This was a huge deal with this eclipse.
It was not that long ago.
No, that's right.
We're still proving general relativity. That we didn't. Gravitational waves were proposed, a very long time ago, and then decades of work to get to the point of detecting this. And when it happened, it's big news. The universe still works the way we said it has been working for the last 100 years.
Einstein was right.
So I will acknowledge here that you are an astrophysicist and an astronomer. You are not zoologist, but I am curious about. I am curious about what you've both observed about whether animal behavior changes in any noticeable way during an eclipse.
It got really quiet during the 2017 eclipse. I'm struggling to remember because I was also so distracted by the eclipse happening. Yeah. But it felt a lot quieter. There are tons of stories about animals behaving, not like, oh my God, something crazy is going on. They don't care that an eclipse is happening, but because you have that eerie twilight kind of light happening and then it gets dark, there's all these things that animals do because they think it's nighttime. We were just talking earlier about it would be fun to be in a zoo and just watch and see what happens.
Yeah. That would be. I think the birds are the most obvious thing for most people. Is there are birds that make noise during the day, and then there are birds that make noise at night. Like I have one outside of my house right now that's at 5 a.m. starts chirping. I'm curious to see. I won't be there, but whether that will happen. And so I think that's the most obvious thing. But I'm like you. I think the problem is totality is so fast that you're just going to concentrate on that. Now this one's longer, so maybe we'll have a chance to notice some of this stuff. But I was saying earlier, I had people who were trying to take selfies in 2017, and you're missing the whole experience. It's so fast that you just really want to enjoy it. So I say pay attention if you can, but also make sure you're experiencing this amazing gift from Mother Nature.
I'm glad you mentioned that because we are all. It just seems natural to want to capture this thing with our phones. I imagine the photos we get won't be all that good anyway.
No. Your memory will be much better. That's what I would say.
I pulled out my phone because people were asking this morning, and I said, if you when you see a beautiful moon low in the sky and you think, I'm going to try to get a photo of this and I'm going to send it to my friends, and it never looks as good as it does. It'll be the same with the eclipse, but even more.
Yeah, agreed. Yeah.
Do either of you ever think about what eclipses must have been like for ancient people who did not have an astronomer in their wandering band? Didn't know what this was.
Well, we have stories about it. I mean, it's really. I think people react all kinds of ways to really unnaturally natural phenomenon, right? I mean that it's either it could be an incredibly bad omen or an incredibly good omen, depending on how things are going. I mean, there's instances of battles being stopped, or it's bad news if an eclipse happens for the king, so we got to do something. I mean, it's hard to imagine because I've known my whole life how eclipses work, but we were also talking earlier. Do you think there's anybody who doesn't know that this eclipse is going to happen?
At this point, it's hard to imagine. It's everywhere, right? but there might be some. I mean, it is such an unreal experience that it must have been truly shocking if people were not prepared for it. I know. I mean, it is unreal. That's the word my dog sitter gave me. She saw 2017. She's like, oh, it was unreal, and I'm like, I love that word. I'm going to use it. When you see it, you're going to go, this isn't real. It can't be, but it really is, and so it really. I'm telling you, just wait till Monday. You'll all believe me on Monday.
It is only possible, right, to view the eclipse before totality with special protective eyewear or through a pinhole camera. I want to go through these a little bit because there's some crazy stuff online, right?
Yep.
So 2 pairs of sunglasses, your welder's helmet, a Mylar balloon will not protect your eyes.
None of that. Nope.
No. You don't want to things like welder's helmets. You don't know what shape it's in. Like you should just get what you know will work, which is those eclipse glasses that are certified and have the right ones, or all of the indirect methods like making a pinhole camera. We've done before. You can make a little design with the pinholes and project it on the ground, and it's just better to be safe than to risk it because you can damage your eyes. But once it's damaged, it's damaged for life. So.
During the annular eclipse, I experienced these crescent-shaped shadows that I was not prepared for until I saw them. What causes those? I mean, that's just obviously just the moon passing in front of the sun.
Yeah, it's the same effect, and you should see that on Monday too. So this is something to look for. I think it's very as the moon starts covering a significant fraction of the eclipse, you can start seeing things like that, and that's super fun because you know kind of where it's going.
In the path of totality, when we achieve totality, we will be able to take those glasses off briefly, right? If someone is not at a public event of some kind, is it possible that, will we know when it's safe to take the glasses off?
So when the way that you can find out if it's safe to take the glasses off, there are a couple of websites. NASA has a lot of great information. The U.S. Naval Observatory has a really great calculator. You can give your coordinates, and it'll give you to the second exactly when it's safe where you are. If you want to know exactly, you know where you're going to be, you can go on a map and plug it all in. I've been telling people if you can get to an event, that's the best way because someone will have looked that up for you, and you can trust them to say, okay, now is the time to take your glasses off, take a look. Okay, now stop looking at the sun or put the glasses back on. That's really the best way to do it. But what's your favorite website for looking that up? What has been your go-to when people ask?
I've just been telling everybody they should check out the NASA solar eclipse in terms of getting the glasses. I think that's, I just want to go back to that and just say it's super important to make sure you get the proper glasses. We've been hearing a lot of news stories about scams and people selling things that aren't legitimate. So definitely you can go there and make sure that the brand you're using is the right place. But you're running out of time, so I better hurry and get them. Right? It's only a few days.
I mean, we are placing a lot of trust in those little paper glasses, but there are certification labels placed on the ones we can count on.
Most of them are fine, and I should say if you see the bright sun, like the surface of the sun, then you probably shouldn't be looking at the sun. The difference is pretty obvious. When the corona is a diffuse thing, you'll know during totality and then as soon as the sun starts emerging, make sure you put your glasses back on. It's not the sort of thing that I don't want to encourage people to, but it's not like it happens in a second and you're going to go blind. But it is, if you're seeing the bright sun, put the glasses back on.
And anyone who is outside the path of totality,
always
they must keep those on while looking at the sun.
That's right. So that's the vast majority of the United States.
Talk a little bit about the other people around you when you saw that eclipse in 2017. What did you observe about other humans and their behavior?
I feel like everybody was gobsmacked. I don't know. Everybody was just, and I think I was with people who hadn't seen an eclipse before, so we all had that same reaction of just not. You're processing it when it's happening because you're seeing something unlike anything else you've seen before. And then even though I think it was maybe 2.5 minutes in 2017, something like that, it still felt like it was over in 10 seconds.
It goes by so fast, so fast. Yeah.
And then, so when it's over, it is anticlimactic, but everybody was sort of like, what just happened? What just happened? And then discussing it for the rest of the night because it's so unreal. When
the totality just happens, there's that moment when everybody's seeing it. There is a gasp. I mean, everybody will make a noise because it's like, oh my God. And then you're right. And I always find it pretty quiet during totality because you're just trying to process what you're actually seeing. And it does. I mean, 2.5 minutes went by the last two for me were about 2.5 minutes, and then went by so fast.
Would you describe it as an emotional experience?
Absolutely. I'm not a terribly spiritual person. I see it's a spiritual experience. It really is. There's really nothing quite like it.
Yeah.
I don't know.
It also strikes me that the eclipse is something that all of us, at least in the United States, the lower 48, can experience some part of with no regard for politics or the things we're arguing over. I mean, this is like an extraordinary shared experience. We don't get many experiences like this anymore.
That's why it's such a great opportunity to get people thinking about the world around them and the universe around them. Not just we always want to inspire the next generation of scientists, but I also want people to sort of just stop and think about the world and everything and how it works. And I don't expect everyone to remember the Saros cycle in every however many years, but just thinking about things are moving and we're a part of something really big and we're all sort of in this together.
When in 2022, when the first James Webb images came, I was giving a lot of talks on James Webb, and I had so many people come up to me and say, it's so nice to be able to hear about this because it takes me away from all the other things that are going on in the world, right? Inflation and this and that. There's the world, you know, the world is, as I post-pandemic, the world is exceptionally challenging, I think, for all of us. We all kind of came out the other side slightly different in some ways we don't always appreciate. And having some joy in the universe and getting to see the amazing things from the universe is I think, a wonderful thing. And this eclipse is a great opportunity because so many people are going to get to experience it.
Why do you think humans need to understand the way the universe works?
I think many people are naturally curious about a lot of things. Whenever I talk to kids about science, like an astronomer is a scientist who just got really interested in trying to figure out what's going on up there. And even before telescopes, it was just people going, well, some of the things up there are moving different than other things. I wonder why that is. And I think that, that can be a really keen interest in wanting to understand why that rock looks different than that rock, or why a certain plant behaves the way it does. And I think that curiosity can take a lot of forms, and that is it can be an expression of creativity and just wanting to understand something. And astronomers just took it to it's not the next level, it's a different level. It's just we really want to know about how space works. And there are lots of different ways to approach that question. I think a lot of people are just naturally curious about why things are the way they are.
I think it tells us about our, it gives us a context for us. I mean, we're very, very small in many ways. When you think of the universe, it's so immense and so incredible, but we are still very special. We don't know of another planet that is quite like Earth. We don't know if there's life out there in the universe. These are questions we're, of course, hoping to address. I personally believe that life is probably very common in the universe, but how common is intelligent life like us? It's taken 4 billion years of evolution to get us to where we are today, where we're on your show, right? And it's like, that's pretty incredible because many stars don't live 4 billion years. We have a very stable star, a stable planet, we have a magnetic field, we have a moon. All these things have led to us being here at this moment. We still don't know how common that is. And to me, of course, that's perhaps the biggest question of all is there life out there? And that's something, as astronomers right now, I think is the kind of our next big question we're really trying to address.
Can we take some questions from the audience?
Oh, absolutely.
Hi, you can hear me, right? Okay. Krys, lovely show again. First time physically here in the audience, so I appreciate the opportunity. What would the eclipse look like for somebody who's on the moon?
That's a really good question. It's really interesting. I guess you would.
You see a shadow go
yeah,
across the Earth.
Yeah, you see a shadow go across the Earth. I mean,
it would be far less interesting, I think.
Yeah, there are pictures from space of the moon's shadow on the Earth's surface from spacecraft, but from the moon it would just, because of the size of the Earth and the moon and all of that, you wouldn't see the sun completely blocked from the Earth.
Yeah, you would see. This is where it's very unusual to give an astronomy presentation like this without pictures, because Jeff and I were talking about this earlier, because we're so used to having pictures. And I was going to say, one thing you might look up is there's beautiful pictures of, for instance, Jupiter, and you can see the moons in front, and you can see the shadows of the moons on the surface of or on the outside of Jupiter. So, I mean, that's an example of probably what you would see from the backside of the moon. It'd still be pretty cool. I think you could see a beautiful. I mean, the Earth is probably, honestly, even though everybody loves Saturn, the Earth is the most interesting planet in the solar system. It's pretty beautiful. We just take it for granted a lot. Saturn's pretty good too, but it's second.
One of the really interesting things in the 2017 eclipse was that sunset effect. And I know the moon is closer, path is wider. Will there be any difference in the sunset effect this time?
I think, I guess it depends on how, it might be a little more pronounced and longer, but I don't know if you'd see a really, really big difference. I think it depends, of course, on where you are. And I think, as Jeff said earlier, like when we were in Chile, it was a very different kind of landscape, and I think that is probably a bigger effect for how you'll experience it than maybe that effect.
Question right here.
I don't know if this is going to be worth this or not now, but I have three questions for you since they're all really quick. First of all, you mentioned sunspots being cooler. I'm curious how much, and how much cooler. And then since that's an easy one, can you as an astrophysicist or an astronomer write off eclipse chasing? And then finally, the astronomer, are those planets or suns or moons on your socks? Thank you.
Oh, very good.
So sunspots are about 1,000 degrees Kelvin cooler. Is that right?
Yeah,
2,000? Yeah.
1,000 or two.
Yeah, everybody knows kelvins, right? Instead of Fahrenheit. I don't know what it is in Fahrenheit. Those are stars on my socks. I didn't have sun socks, and
I didn't bring
what
mine.
was it? Writing off eclipses. I mean it's really.
This is a work trip, if that's
Yeah.
what you're asking. Yeah,
But
it is absolutely a work trip. Yes, and we are working. Trust me, we've been doing interviews and talking. Jeff went and saw some children this morning. We're doing a lot this week, but the answer is yes. It most definitely is a work trip. We've been planning this trip to Dallas for us for at least 3 or 4 years. Yeah.
I realize this isn't your field, but this weekend there was an article in the Dallas Morning News suggesting that cloud cover during totality would lessen. I had this experience in Jefferson City, Missouri in 17, and I'm wondering what your feeling is on this.
I'm hoping I don't find out. It will definitely lessen. So, I mean, what we're really hoping for is, I'm hoping if there are clouds, it was like today, this afternoon, where there were a few clouds and a lot of blue, that would be okay. But if it's very, very cloudy, yeah, you unfortunately will miss the real experience of totality, and we'll have to wait till 26 to go to Greenland.
in terms of actual direct effect on clouds, that's really interesting. I'd have to.
Oh, sorry, did I miss the
No, well,
question?
no,
Yeah.
it's whether it would actually impact cloud cover.
Oh,
and
yeah.
Maybe. Now I'm going to look up meteorological effects of eclipses.
Next time we need a meteorologist with us. I wonder how well this is actually studied, because it happens so infrequently at any particular place. My guess is that there aren't a lot of people who've studied this.
We'll apply for a grant.
Yeah, there you go.
Do both of you know specifically where you will be during the eclipse, where you'll watch it from?
Oh, yes. We've known for a while. Well, you're going to be here
I'll be right here. Yep.
at the Pro. So we have a lot of people coming here for the Pro. I don't know how many people, 7,000?
Oh, I thought you meant astronomers. Yeah.
Oh, no. Actually, the general public. So and I'll be here in Dallas as well. Dallas has the best, it's pretty long because of the totality. And in theory, the weather should be historically better here than other places. So we'll just have to see if that holds.
Thank you. Can you guys explain why it's so creepy again before the eclipse, like as leading up to?
Well, he said eerie. I'll say creepy. I think it's the light is very gray, and it's the middle of the day. It's creepy. You're just gonna have to experience it. And I think it's just the filtering of the sunlight. It's just something you've never seen. The sun is still out. I mean, you would still see the sun as the sun, but the vast majority of it is being blocked by the moon. And so you just get this very weird, gray, eerie, creepy thing. I don't know.
I think the colors.
Yeah, that's a good slate's a good description.
It's not right even compared to a sunset. It doesn't look quite right. And now I'm really curious. Now we got like another grant to study the color effects.
Yes, there must be one. I believe it's because the sun is high in the sky
Yeah.
when it's happening, and normally, it's not like at sunset or sunrise where the sun is low and it's going through a lot of the atmosphere. Here it's a very different effect in the middle of the day.
Yeah.
But I hope you get to experience it on Monday.
So, if you had the opportunity, would you take one of those eclipse flights where it follows the totality, or would you rather have a more traditional experience?
We just
We
talked
just talked about this before. Yeah.
I feel like if someone paid for me to go on an airplane and I weren't going, I think I'd rather not be in an airplane, just because you want to be able to see the sky as a whole, and they haven't made glass-topped airplanes yet, so.
Yeah. I think it's got to be such a different experience. I think you're missing the real experience of Mother Nature during this. So for me, absolutely, I'd rather be on the ground. I spent a lot of time on airplanes already. I don't want to be on an airplane now.
All right, last question is mine. Do you have some way of evoking good weather on Monday?
Let's hope.
If I check the app 10 times every 5 minutes, I think that's going to do it.
I'm 2 for 2 so far. I should say that in 2019 we had an eclipse in Chile, as I mentioned. Chile has amazing weather, except it was in the middle of the Chilean winter, which the odds are like 50-50, and it was beautiful. And 2017 was beautiful along most of the entire path in 2017. So we'll see. Fingers crossed for Monday.
Thank you so much for spending this time with us.
Thanks for having us.
Great. Thank you.